So good morning everybody, myself Acharya Vishvendra, and today I'm going to discuss about the PN junction, discuss a worksheet on that. So let's begin with things in proper perspectives. Well, here is the worksheet on PN junction. So first question is how a PN junction is made. So there are three steps involved. The first is take a p-type wafer. Next is add impurities, pentavalent impurities to it, and because of that you will have a n-type, a p-type and a junction between them. Next is what is depletion layer. So depletion layer is the central layer when you form a PN junction which is charge free and has got very high resistance or very low conductivity, and it is depleted of the free charges in that region. That's why it is called the depletion layer. Next is why depletion layer has larger resistivity, because it is charge free. So it's very hard to make charges move across that. For moving charges across the depletion layer, you have to apply a certain voltage, which is called the barrier voltage. Next is how is junction field related to width of depletion layer. So suppose this is a width W. We have the relation that potential difference is electric field into the distance between them. So E into W, that gives electric field as delta V by W. So that is the relation between the potential difference or the barrier voltage and the width of the depletion layer. Next is what is diffusion current. So basically the current due to concentration difference is called the diffusion current. So if you make a PN junction, then on P side we have holes as the majority charge carriers, and on N sides we have electrons as the majority charge carriers. So when you mix these two, then there is a flow of holes from P side to N side and of electrons from N side to P side due to the concentration difference. So because of that, the current which is generated is called the diffusion current. Next is what is drift current. So when charges starts getting diffused from P to N or N to P, then there is a depletion layer formation, and because of the depletion layer formation there exists an electric field which is directed from N side to P side, which opposes the diffusion, and current starts in the opposite direction. That current we call as the drift current. Next is at equilibrium ratio of diffusion and drift current. So both are equal, so that is equal to 1. Next is what is barrier voltage. So barrier voltage is the minimum voltage required to move charges across depletion layer. Next is barrier voltage for germanium silicon. So these are 0.3 and 0.7 volt respectively. Next is what is biasing. So applying external voltage on the PN junction is called as the biasing. Next is what is forward biasing. So when P side is connected to the positive and N side to the negative terminal of the battery, that is called forward biasing. And the impact is that depletion layer width decreases in this, and hence barrier voltage decreases. So in a way it amplifies the, or you can say that it increases, it helps in the flow of current, or current is relatively more in forward biasing as compared to the normal diode. Next is what is reverse biasing. So if you just inverse the connections, that is connect P to the negative and N to the positive terminal, it is called the reverse biasing. Here depletion layer width increases, barrier voltage increases, and it becomes difficult for the flow of current. Next is we are being given a question based on diodes. So obviously first one is in forward bias, second is reverse bias, so it's going to produce infinite resistance IGT. So the circuit will be like this. We need to find I1. You can see that current here is 0, so this resistance and this will be in series. So current will be 50 upon 5 plus 20, which is 2 ampere. Then there will be no current through the lower diode, which is 0, and the current through 20 ohm will be I1 plus I2, which is 2 ampere, 20 ampere. So 2 ampere. So in this way we can say that you can optimize your time and energy, and can learn physics better and can improve your problem solving skills. So I hope these will benefit you in optimal preparation of JEE Main and NEET exam. So these will help you out. Thank you and have a nice day.